Hey everyone, and welcome to this video in our continuing algebra series. This one, in terms of linear relationships, is all about the distance of a line segment. So picking 2 points on a line and finding out how far apart they are, and also finding out where is the point that is directly in the middle of those two, and that is our midpoint. So we're using line segments for this particular lesson. Normally we would talk about lines in linear relationships as being quite infinite. Alright, so never ending, that is an infinite number of points on the line. For this lesson though, we're just going to pick 2 points, or have 2 points given to us, and we're going to find this information. Now for distance, or the length of the line, we can actually relate this back to good old Pythagoras' theorem. So if you remember Pythagoras' theorem, was that the square of the hypotenuse was equal to the sum of the square of the other two sides. And the way we wrote that down was c squared equals a squared plus b squared. Now you might have a squared plus b squared equals c squared. Doesn't matter, both equal to each other. What it does mean though is that we can apply this to our points on the graph to determine how far apart they are. Because all we need to do is chuck in our right angled triangle, which we've done previously to find some gradient as well when we've been using rise over run as an idea. So how it becomes in terms of our distance formula. So we do use a formula for this, and it is related highly to Pythagoras' theorem. You can see here we've already decided that that's the second spot. We've already decided that's the first spot. So we're going to find the difference between the two x's, square it. The difference between the two y's, square it. And that's a and b. Okay? So the a squared is like the difference between the two x's. The b squared is the difference between the two y's, and our c squared is our hypotenuse, or the length of our line or line segment. It becomes then, instead of being c squared, because when we do this, we can go c equals the square root of a squared plus b squared. So this is where we end up to find our solutions. This relates to what we're doing here. With the distance formula, okay, as being d for distance, alright, that is now our c, and we get our square root sign started. It's just a little bit easier to start it first. I want the difference between the two. So I'm going to go x2, so the second x minus the first x, all squared. I'm going to add that to the second y minus the first y, all squared, all under a square root sign. So that is our distance formula, and we'll see that in action very shortly. The other thing we need to be able to do is find that midpoint. And you can see our midpoint is the uppercase M. Our gradient is our lowercase m, and our midpoint is our uppercase M. Very important that we get those two very distinct. Okay, so what we're going to do now is we're actually going to find the average between our two x's and the average between our two y's, and those two answers will give us the coordinates of our midpoint. So our midpoint then has this as a formula. Capital M or uppercase M equals, I'm going to keep this in some big brackets, x, or the first x, plus the second x divided by 2, because we're finding an average. If you remember back to data, when you're finding an average, you add the things up, divide by how many is there. We have 2 x's to add up, so we have to divide by 2. And the same with our y's. And then close it all off. And that will give us the coordinates for our midpoint. Okay, time to jump to some examples and see how this all works. All right. Here's our first example. Find the exact distance between each pair of points. And we're going to jump straight into using that formula. So I'm going to start with D. I'm actually going to write this formula down every single time. And the reason I write the formula down every single time is because it's a really good reminder of what we've got to put where. It also helps when you're actually doing your calculations to know you've got them in the right spot. Alright, so point 1, point 2. So x2 is going to be that 1, so the second x is a 1, minus 0 all squared, plus 7, minus 2 all squared, all under our square root sign. Now for these ones too, we do want to try and keep exact answers. We don't want to get really long decimals. So what we're going to do is we're not going to use the calculator for these ones. We're just going to find the final solution with a square root sign under it. So we have 1 squared plus 5 squared, or 1 plus 25, which equals the square root of 26. Now that's not a square number, so it's not going to get us a nice easy response. So what we're going to do is we're just going to leave it as the square root of 26. Okay, just leave it as the square root of 26 because we can't really do a lot else with it. Now the next one, same process. And I'm starting just like before with my formula, just so I remember exactly what I've got to do. And that's really handy. There's 1, there's 2. So second x, 4 minus 3 all squared, plus minus 1 minus 8 all squared. Alright, so what have we got? We have 4 minus 3, well that's going to be 4 plus 3, so that's going to be 7 squared. Minus 1 minus 8 becomes minus 9 squared. And I'm putting it in the brackets because if I don't, it's going to be assumed that it's minus 1 times 9 squared, which would give us a negative answer. We don't actually want that. We want a positive response. So now we have 49 plus 81, which gets us to 130 units. Now there are some things we can do when we have square roots that don't calculate nicely to whole numbers. This is not the time for that. We'll do that at another time. Let's look at a midpoint question now. I'm going to find the midpoint of the line segment that joins these 2 points. So again, I want point 1 and I want a point 2. It's my uppercase M. average of the x's and the average of the y's. Okay, and we can do it all as once. We don't have to do it individually, we can do it all at once. So we have minus 3 plus 2 all over 2, and we have minus 5 plus 8 all over 2. So minus 3 plus 2, well, that's minus 1 over 2. Minus 5 plus 8, that's going to be 3 over 2. And we can actually leave that there. Or we can say it's minus a half and 1 1/2. Or we could change them to decimals and have minus 0.5 and 1.5. Doesn't really matter. Okay. One last example before we finish this video. We have a slightly more problematic question. Find the values of a if the distance between 2a and 4, 9 is the square root of 5. We've got you a little bit of a graph here if you'd really like to try draw it. I'm less likely to. Okay. We can see how it looks graphically a little bit later. But all I'm going to do is I'm going to set up my formula as I did before, and I have every other time. This one's a distance question. Okay, so I'm going to use my distance formula. There's my distance formula, and I just start plugging in exactly what we have. So our distance is the square root of 5. And then under over here, we can put in all our other bits. So we know the x's, but we only know one of the y's, but we'll keep putting it in because that's what we need. So now we can keep going. We've got the square root of 5, and underneath our square root sign we now have 2 squared 9 minus a all squared. Alright, if we get rid of those square root signs, so we square everything, we get 5 and 4 plus 9 minus a all squared. Now what we can do is we can do a little bit of algebra and take that 4 away from both sides. Gives me 1 equals 9 minus a all squared. Now I can find the square root of these numbers quite easily. Alright, so for this one here I have squared everything. And now I'm going to find the square root. Okay, so square root of 1 is actually plus or minus 1. So it's a plus 1 or it's a negative 1. So I'm going to use my plus minus sign and the 1. If I square 9 minus a, the whole thing's all squared, I'm actually going to get 9 minus a. Okay, so then I have two options. I have 9 minus a equals 1, or I have 9 minus a equals minus 1. Okay. So all that means is if I take away the 9 from both sides, it'll get a little bit screwy on us, but we can just look at these as one-step equations. Okay, 9 minus what is going to give us 1? Well, 9 minus 8 is going to give us 1. 9 minus what gives us minus 1? Well, taking away 10 from 9 will get us minus 1. And that's where we're at. So if I was to plot this, say I have my 4. Alright, and then there's my point. Then my 2 potential points for this. There's going to be my 2. There's my 9 on the y-axis. I'm going to have either 2, 8, which is right here, or 2, 10, which is there. So that's 2, 10. And that's 2, 8. And then this distance in here is the square root of 5. And that distance in there is also the square root of 5. So that's just how it looks graphically. And if you've done all the calculations correctly in your algebra, that's where you should get to. Okay, as usual, these questions have come out of a Cambridge textbook. You do have some class questions to do. If you have any questions, you can comment on the video, or you can send a question through Teams. Good luck.